Hi, I'm Dr. Katie O'Sullivan. I'm the faculty advisor for the Geology SURE group.
Hi, and I'm Brianna Acevedo, and I'm the graduate student assistant for this project.
And it is our pleasure to introduce the 2021 SURE Geology students who are determining the abundance and chemical composition of mafic crystals in a lunar meteorite.
Hi, my name is Jennifer Wilcaba, and today we'll be introducing the abstract. The origin of the moon is a topic that is enthusiastically debated due to the limited amount of samples returned from the surface. Just after the moon formed, it is thought that the moon had a lunar magma ocean, a vast world of flowing magma that reached unknown depths. The precise chemical nature of the magma ocean is unknown, but can be elucidated with chemical analysis of rocks from a wide variety of locales. In particular, olivine, plagioclase, and pyroxene crystals, termed mafic crystals, record chemical changes in the lunar magma ocean. Lunar meteorites can contain new types of rocks because they can come from anywhere on the moon. I will now be passing it on to the next intern.
Hi, my name is Alyssa Montejo, and I will be doing the rest of the abstract. The focus of this study is a new meteorite, Northwest Africa 11788, which can be seen in Figure 1, that has not been analyzed before. The sample contains rock pieces rich in olivine, plagioclase, and pyroxene crystals. In this study, we analyzed the chemistry of olivine, plagioclase, and pyroxene crystals to determine if any new rock types exist in the sample. We also determined which thin sections contained abundant mafic crystals and therefore should be targeted for future chemical analysis. I will now be passing it over to the next intern.
Hello, I'm Rosalie Cruz, and I'll be talking about the methodology for our research. So our sample was sliced into 18 sections that were mounted to glass slides so they can be viewed with a petrographic microscope. Using a petrographic microscope, mafic crystals were identified in each section. Photomosaics were assembled for 7 thin sections, which you can see on figures 2 and 3. Chemical analysis of mafic crystals were obtained for 5 sections using an electric microbe at the Colorado State University, which you can see the image in figure 4. And chemical analyses of mafic crystals was compared to published data to determine if any new rock types are present in our sample, which is the Northwest Africa 11788. I will now be passing this to the next researcher that will explain our results.
Hello, my name is Tara Bonus, and I will be going over the results. So for our results, you can see they are shown in figures 5 through 8. And so for figure 5 in the middle, pyroxene exhibits a much wider range of compositions than previous studies. And you can see that by our data points are the green points, and they show a much wider range than the red and blue points, which are previous published data. And in figure 7, you can see that the olivine in our sample has a lower magnesium number, which is shown on the left side here. And the plagioclase has a wider range of anorthite percent compared to published data. And again, this is the colored points are our data, and then the gray data points are the published data. And also for figure 7, you can see that a few rock fragments fall outside of the range of previous studies, and that would be these points over here. And so those are worth investigating a little bit more. And so for figure 6, which is over here, you can see that olivine in this study has a lower magnesium number overall and a higher amount of chromium number compared to previous studies. And in figure 8, the magnesium number and the chromium number of the spinel mineral has a lower chromium number, which you can see by these ones over here. And the magnesium number is a little bit higher, but also lower compared to the published data points. And so that is it. I will now be passing it on to my fellow student.
Hello everyone, my name is Brian Aguilar, and I'll be going over the conclusion. The mafic crystals in the NWA 11788 have a wider range of composition compared to previous studies. As seen in figures 5, 6, 7, and 8, they indicate that a new rock type may be present in the sample. Some data points have low or high abundances of elements. As for example, the points with the high chromium in figure 6 and low magnesium number in figure 8. Further investigation is needed to determine if these are true outliers. New rock types can help constrain the chemical nature of the lunar magma ocean hypothesis. And now I will be having the next intern come in to finish the future work.
Hello, my name is Amrit, and I will be talking about the future work that we will be doing later on as taking this work into consideration. So for future, as we can see in figure 9 over here, let me just go ahead and zoom in. So we will be using laser ablation inductively coupled plasma mass spectrometer, and we'll be using that to trace elements while getting the chemical analysis of them. And once we have the trace element results, then we will be comparing those to the literature data that we had gotten, and then we will put it into context with the lunar magma ocean models for the comparison purposes. And along with that, as we can see over here in figure 10 and 11 over here, we can see that they contain a lot of abundant mafic crystals, and these are the additional sections that we will be prioritizing for future research. And we will do chemical analysis on those as well. And overall, me, along with my team members, we would just like to give a special thanks to Chevron and Title BB Graduate Excellence Program for funding the SHORE program at CSUB and allowing us to conduct this research along with Dr. Katie O'Sullivan. And we would also like to thank Brianna as well. And overall, thank you so much. Have a great day.